Hello, Professor. My name is Amir Saman Ahmadi, and today I'm going to present about my assignment, Milestone 6. So, throughout this presentation, I'm going to go through the introduction, data acquisition, uh, web crawling, data preparation, modeling, and so on. So, for any data mining project, firstly, we need to understand the business and as well as the data, prepare the data, do the model, evaluate, and continue with the development. So for this project, we decided to crawl the data from 3 different websites: the stock data from the Star News, and oil and gas, gold and silver data from investing, as well as news data from the age markets. So for the Star News, we decided to go take the things a little bit further, and instead of crawling the website daily, we decided to get the data from the graph. So as you can see here, in the Star News, we can get a graph like this for each company. So we decided to inspect the graph a little bit more and using XHR and JSON file. So once we get the JSON file, we could extract the data from there and then save it in SQL and HDFS. Same thing goes with the crawling for oil and gas data. As you can see here, this is the data that we could find from the JSON file. This one wasn't graph, but somehow we could find the JSON. So we extract the data from here and then make the SQL and add it to SQL as well as HDFS. However, for the age market, it was a little bit different because here we did not have any kind of JSON file, so we need to apply different type of techniques to crawl the data. So we we open the website and start searching the company name that we are looking for one by one inside the search result, and we crawl those data, such as the headline as well as the article itself. Later on, I will explain more when I show you the code. After we crawl the data, we start to look for the missing values, outliers, and visualizing the data to find out more about the data that we have. And then also we try to combine this data and try to make keep the necessary data only and dimension reduction. So as you can see here, for example, for this is a gold date, we have time 2015, 25 of March 2015, but we have time. However, for this studies, I have decided to use only the last months, so I needed to remove the time so I can match these data together. So the date become like this. This become my index, and then I have the gold price, silver price, oil price, and gas price in one data frame. However, for the news data is a little bit different. We needed to do the sentimental analysis and text mining. So as you can see here, after we do the correlation, we combine this data, we could get the polarity for the article as well as headline. And also I have decided to make a new function to tell the category of the news polarity, which might be useful later on. And then after this step, we convert the data to SAS format so we can start building our model in SAS. So this is how it's look like, the data for one of the companies. I decided to study on 4 companies: AirAsia, Petronas, Gamuda, and TM. So I went and make the decision tree as well as regression. So this is a summary of the models that we input. I put inside the SAS So gas price, gold price, news polarity, oil price, polarity category, silver price, and as well as stock price. And a basic analysis on it, I can get a mean. As you can see, we have no missing value because I have done the data pre-processing earlier. So here I just import the clean data, so no imputation needed. And this is what I could get, for example, for Gamuda. Could calculate it for the correlation as well as information gain. These are the correlation with the stock price. Here our stock price is a target value. So we can see that oil price has the higher information gain. So we decided to keep it as the first branch. And after that, the news data or polarity cat. In this data, even though my accuracy is not that high, however, it is good for the 1 month data. The accuracy here is around 60 or 70%. And another one is, this one is for TM. And for TM, we can see that again, oil price has the highest information gain compared to the other features. And after I make the regression and I build the model, I could get around 88% accuracy. So the blue line is the predicted one, and the red one is the actual value. So as a conclusion of this project, I can say that Gamuda, Petronas, and AirAsia are very correlated with the selected features. However, we need to do more enhancing on our features. Maybe we can add more features and also more data in order to increase our accuracy from like 60-70% to somewhere around 90 or 98%. And throughout these studies, I could find out that gold and silver has a direct relationship, meaning if gold price increase with the same constant, silver price also will increase. And for Telecom Malaysia stocks is highly related to oil price. Even the Telecom Malaysia is a computer company, however, it is related to oil price. It was one of my findings. Therefore, for the end user, if someone is here is Telecom Malaysia or TM stockholder, can use this model in order to increase their profit because we have 88% accuracy, so it's something good. And all the source code can be found here in the GitHub. I have already uploaded it in the GitHub. Yep, as you can see here, I put the final code for each part of this study, combining, cleaning, and so on, as well as source data and the data itself, the CSV. Even though if you run the code, you can get the CSV file. However, I upload the CSV file here as well. So just looking into the code. Okay, since the gas, gold, oil, and silver price has been crawled from one website, so they basically followed a similar step here. So, for example, this is the link that we used. I showed you in the picture. You can have a look. It's basically a JSON file, which this one look like. So, for example, we crawl the data from here. And so technically the library used here was JSON as well as request. Similar thing applied to gold, oil, and silver. And once we got this data, we imported it into a different table. But for stock price, it was a little bit different. I decided to crawl the data based on each categories, not alphabet. So if you look into the data set that I have right now, I crawled the categories and subcategory of each company as well, which can be used in terms of studies. So here I got the company name, here I got the date, and here I pass it into my SQL. So these are the things that has been passed into the SQL. For the news data, however, it was a little bit more different because here we could not use any kind of JSON. So it is we used beautiful soup and selling beautiful soup and request. So we get the URL, we build a new URL. Once we get the header and headline of the data, and then we pass that new URL into the company, into the website, and then we start getting the news date, company name, headline, article, and news URL. And once we got that, we pass it into the SQL file. However, since I was studying for 4 companies only, I give the company names here. But for example, CIMB or Sapang or Tenga, it was additional data that I wanted to have. So later on, when I select the data, it give me accurate data. It's not only one data, so I need to separate it later on. And this is the end of final link. So this is the data cleaning part. I look for the missing values. The April data is the stock data, which I separated it for only April. And the news data, the one that we have. And I have imported the combined data. What is combined data? Combined data is here. Again, looking for missing values. So I imported gold, silver, oil, as well as gas here. I dropped the unnecessary columns such as ID and created add. Look for the missing values. As you can see, there is no missing values. Then I changed the date format. For example, you see here there is time. I remove the time, so I later on can match them together nicely. This is a per plot, for example, for gold. And I look at, and this one is for silver, and I look at the data from I took the data from 1st of April onwards. Same thing goes for oil as well as per plot. As you can see, these are the graphs for example, open price, high price, low price, close price, and volume. We can see all this data is highly correlated. Therefore, I decided to pick the close price because, as you can see, it's the same with others, not much difference. So I make a new data set like this. So this is my final data set: date, gold, silver, oil, and gas. So I saved this data, I imported it here, and I dropped the unnecessary ones, look for missing values, describe the data to see. This one is like the main category and subcategory. Look at for the unique sectors as well as subsectors. So we have like 5 sectors and few subsectors. Same thing goes for the news date. We have a problem with time here, so I needed to change the data. If I imported it here, you can see, yeah, for example, see the new date, the format is like this: April 30, 10 a.m. So firstly, I changed the date to this, and then from this, I needed to change it to form date format. So I removed the time. Then I calculated for the headline polarity and as well as article polarity. As you can see, the headline polarity doesn't give much. Article give me more information. However, I decided to keep this one as well and sum this excess. So headline plus the article. That's how I calculated it. So with that, I can get the polarity. And then I separated each company for the news. This one is the, for example, Petronas. For example, in this data, wherever the company name is Petronas, it will be selected for the Petronas. Wherever is equal to TM, it will be selected for TM. Then I put the news date as the index, get the business day, and sum. This one, for example, if in one day we have few news for one company, it will combine it and make it into one. So it will sum all of them together, and this is what I will get. For example, 2, 3, 4. These are the dates and headline, article, and the polarity for that particular day. I make a new function. For example, if it's above 0, it's considered positive, below 0 negative, and yeah. So I applied this function into each data set. So I get the new column. This one is for plotting, count plot. So, for example, if I want to run one of them, actually, if I want to do that, I need to run from the beginning. It's okay. Because it's time consuming. Later on, you can look at this code. It's already on GitHub. And then same method and approach has been done for the stock. So I selected only the stock, the name. For example, oh, sorry. Here is the place that I changed the stock date format. The date format has changed. And I selected from 1 to 4, so the date will be the same. See, that's how it's gonna look like. Then here I needed to change the format, even though it does look the same, but I needed to make it different, make it into data time format so I actually can use it. And then I make a new data set, for example, for Petronas. It's gonna become like this. Same thing goes to TN, Gamuda, Eurasia. And then apply the polarity cat. So each of them will get the category, the one I said. And this is gonna be a per plot, for example, for Petronas. That's how it's look like. And then the covariance, correlation, heat map, count plot. The one that up there, I already did it here, so you can see for each company, and that's all. After this, I saved this data and I brought it to SAS. So the format, as you can see here, is changed, and these are the studies for each company separately. For example, Gamuda, you can see that this is my result. This is my covariance. Correlation. And for example, these are my inputs, and data partition, I put it 70% training and 30% validation. For example, the decision tree, if you want to see, this is going to be my decision tree. All price, vertical, and the regression results. That is my regression, and you can see here about accuracy. Sorry, yeah. See, it's around 61%. It can be improved. Another other companies, and for example, TM, if you want to look at the accuracy, you can see that the accuracy here is 88%. So basically, that's all for my project, and thank you.